Hey everyone, today we're going to be talking about how to graph a square root function. So what you see on top of the screen is just kind of a little bit of review of things that we've done in our previous units or things that you might have done in Integrated 2. I wanted to show you the answers here with all of the work just in case you were interested in seeing it. Exponents is going to become really important in second semester, and so remembering those exponent rules and utilizing them is going to be really, really important. So if for some reason you're struggling with exponents or you need a little bit of help, please feel free to reach out to me and I can talk to you about those. Your AH and K we've been going over the last few days, and then of course your factoring by grouping, and we want to make sure that we continue to know how to factor. So our square root function, as you can see in the second box, looks kind of like just like a little kind of a side curve. You'll notice that instead of 3 reference points for a square root function, it only has 2. And the reason for that is because it curves more like looking like a C than it would be like a squiggle, kind of like the cubic functions are. And so we have reference points of 0, 0, and 1, 1. So those are going to be really important to understand. The other thing that is different about a square root function is the domain and range is not going to always be negative infinity to positive infinity. It's going to essentially be 0 to infinity or for both domain and range. Now, please realize that the zeros will change based on the h and the k. So depending on what you have for your h and your k in these functions, the domain will be based on those. And we'll talk about that on the next lower part. Lower on this note page, you'll see the transformations, and that's just kind of a recap of what a, b, h, and k does. So again, kind of review it, make sure that you're understanding what a stretch and compression is, whether it's moving left, right, up, or down, and so forth. All right, so I wanted to focus on our domain and range and understanding how to find the domain and range. So we have this example, a of x, where we have a is the 4, and you have your h, which is -3, and your k is -5. So what you're going to see is that domain is going to be figured out based on what's inside your radicand. So basically the inside part of the radical. So if we set it equal to 0 and solve, that would give us our domain value. Our range is just going to be our k value, so a lot more simple. So if we put x plus 3 equal to 0 and we solved, we would get x is equal to -3. So what we're going to be doing is we'll have a domain of -3 to infinity, okay? So the first essential value is -3 there. Now, I know that a lot of you might be thinking, okay, well, that just looks like the h, Ms. Strickland. A lot of the times it is just the h. It just depends if there happens to be a number in front of the x, and then you want to solve it completely, because then that number will change. So just be careful if it's not just x and it's like, let's say 2x or a half x or something like that. You do want to go ahead and completely solve it. So our range is just based on our k value. So that first point is going to be our k, which is -5, and then it will go to infinity. Now, one thing to note as well is that the a will change the range, okay? So if a is negative, the range will flip. And so instead of going to positive infinity, it will actually be going to negative infinity. And you'll see that in one of the examples on the next slide. All right, so we're going to go ahead and go over some examples now that you have a better idea of what the square root function is and how to find its domain and range. So the first thing we're going to do is we're going to identify our a, h, and k. So remember, although the steps say a, b, h, and k, remember that it's really important for us to, we're going to only focus on a, h, and k and not the b, okay? So what you have is you have your a, which is a half, which is a vertical compression because it's less than 1. You have your h, which is 3, so that means it's going to move right 3 units. And you have your k, which is -1, which means it's going to move down. Now, I am going to show you using the reference point method. Remember, if you wanted to, though, you could just do exactly what we did in class. So you start with your h and k, so 3, -1, and then you would move up a half and then over right 1 if you wanted to. So using the reference points, we're going to go ahead and multiply our y values by a half. And that's going to be our vertical compression, and it's going to show us how our points will move. So obviously 0, 0 is not going to be affected, and 1 times a half is going to be a half. And then we're going to go ahead and apply the h and the k. So we're going to add 3 to the x coordinates and subtract 1 to the y coordinates. And that will give us our 3, -1 and our 4, -1/2. And so you'll notice that if we use just the method we were using in Zoom, if you put 3, -1, which is your HK, and then you go up a half over 1, you'll get your second point. And the key thing to remember about the square root function is what it looks like or how it looks like, and it's just going to start at your h and k and then move through your second reference point. And so a lot of the times students get a hard time because they mix up the cube root function with the square root function. So you really want to make sure that you understand what it looks like, because it's different than the other two functions we've been talking about so far. We want to also state the domain and range. So remember, your domain is going to be based on your inside of your radicand, or the inside of the radical. So if we set x minus 3 equal to 0, we would get 3. And then our range is going to be based on our k, and so we'll get -1 comma infinity. Notice that our a here was positive, so we didn't have to change the range to be negative infinity. It stayed as positive infinity. So let's go ahead and do another example. So we're going to start by identifying our a, h, and k. So our a here is -3, which is going to be a vertical stretch, and it's going to be a reflection because it's negative. Your h is going to be 2, which is going to make it move right 2 units, and your k is going to be 1, which means it will move up 1 unit. So again, if you were doing the Zoom method or the one that we were doing in class, we'd have a reference point of 2, 1, and then we would go up 3, left 1. We go down 3, right 1, because of it being -3. And so we're going to go ahead and multiply the -3 by the y's. So 0, 0 stays the same. 1 times -3 is -3. And then we'll add 2 to the x's and add 1 to the y's. And so that's going to give our reference point of 2, 1, like I just mentioned, and then 3, -2. And so if you plot this point of 2, 1, and then remember we would go down 3, right 1. So down 3, right 1, you'll notice that that gives you the 3, -2. And then again, because it's a reflection, be very, very careful. We start with the h and k and then put our line through those points to give us our square root function. And so our domain, again, is going to be based on the radicand, so the inside of the radical. And our range here, because a is negative, will switch to be negative infinity first to that +1, okay? So anytime we have the a become negative, just know the range will also be negative infinity instead of positive infinity. So what I would like you to do now is I would love for you to pause the video and try C and D on your own. And then what we'll do is we'll go over C and D together as a class. Okay, so let's go ahead and we're going to identify our A, H, and K for C. So we have 2, which is a vertical stretch for our A. We have H is 1, which is moving to the right one, and our K is -4, so it means we move down. We start with our reference points of 0, 0, and 1, 1. If we multiply our y values by 2, the 0, 0 won't change, but then I have 1, 2. Okay, and then we're going to apply the h and the k to the x and the y. So add 1 to the x's, -4 to the y's, and we get 1, -4 and 2, -2. And so again, if you were using just the method of HK, so we're going to graph 1, -4. A is 2, so that means from H and K we would go up to right 1. And if we went up to right 1, we would get that 2, -2. And then remember, it's going to start with H and then curve out from there. Okay, so because A is positive, both of these will go to infinity. So our domain will be +1 to infinity, and our range is going to be from -4 to infinity. Okay, last one that we have, we're going to identify our A, H, and K. So there is no A here, so there's no movement, or A is just 1 essentially, so there's no stretch, no compression. And then your H is going to be left 2 units, and your K is going to be down 4 units. We'll start with the reference points 0, 0, and 1, 1. We're going to go ahead and skip the A, so no multiplication here because A is just 1, because anything times 1 is itself. But then we will apply the H and the K, so we'll -2 units and -4 units to the y. So we'll get -2, -4, and then we'll get -1, -3. So if we were graphing these without doing what I just did, we would start with the H, K, so -2, -4, and then since the A is 1, we would just move up 1, right 1. And you can see that's what it does. And then we'll go ahead and graph that curve, starting with the H, K. Notice the A is positive, so our domain and range will go to positive infinity, and they'll be based on what's inside the radicand and the K value. All right, so that concludes today's notes on square root functions. We're not going to be writing the equation of these functions for this note page. We're just going to go ahead and graph them and understand the domain and range. So just know that you can write the equation from this function, but we're not going to spend much time on it this semester. We might come back to it again next semester. So I look forward to seeing you guys in Zoom, and have a great rest of your day.